What's going on, you guys? Welcome back to the channel, and today's video is going to be showing you how to build this complete Yahtzee game completely in Python using the PyGame module. So I'm super excited to give you guys this full tutorial. The number one thing I've been getting asked on a lot of the bigger projects is there a GitHub repository where you can just download the whole project file? And I hadn't been doing that for some of the larger files because being a YouTube content creator, having the watch time really helps. But for this project, I did make one. I'll add a link to it in the comments. It is just plamaster01 and then Lamaster Tech YouTube, and then this is the yahtzee.py file. Again, I'll put a link to it in the comments. You can go, if you're just here for the code though, before you grab that and leave, maybe leave a like on the video, just say thanks for the code. It's got everything in there that you need. So even if you do want to follow along with the tutorial, but you don't necessarily want to have to type all of this out, because there is a lot of like drawing stuff and calling things over and over again, then maybe you want to download it anyway. So feel free to go check that out. The project takes about 2 hours, but you're going to be at like a pretty full functioning Yahtzee game in like an hour and a half of time. And then the rest is kind of adding to it. So I recommend going through the tutorial. You can watch it on 2x speed if you want to just download the program first, but hopefully you find it super useful. If you do enjoy the tutorial, please consider subscribing to the channel. I'm fairly new, and just the support that I have been getting has been really great. It helps me keep making new content. And without any further ado, let's just get into the tutorial. Thanks. All right, to get started, we're going to set up the game using a few modules that almost every game is going to use. So we're going to import two things. We're going to import random, and we're going to import PyGame. And if you've watched any of the previous video game tutorials on the channel, you're probably super familiar with the fact that you have to do PyGame and then PyGame.init. And a lot of the next steps we're going to do in just setting up how the game works are probably pretty familiar to you. So go ahead and skip to the next chapter if you don't need help on just fundamentals of PyGame. But let's assume you're here for the whole thing. So after I do PyGame.init, I'm going to go ahead and do width and a height variable. And I like to make these variables because then when I'm creating my screen and drawing things on the screen, you can make it dependent on those variables. So that makes it very quickly resizable. So then for setting up a screen, an actual place to display everything and use those variables, it's pygame.display.setMode. I can just get typing sometimes. Pygame.display.setMode, and then in square brackets you give it a width and a height. And in this case we put our width and our height into variables, but you could just type 600 and 800 there if you wanted. And screen size is one of those things you can play around with the sizing of everything throughout our game and just decide what works for you. I liked 600 by 800. And the second thing is I always just like to set the caption of the screen. So when you open a window, this is the text that's up at the top, and if you don't set it at all, it says like PyGame window, something like that. And since we're making Yahtzee, we'll call it Yahtzee. And then something you're going to want in every game is pygame.time.clock, and store that clock in a variable that I always call timer, and I create a frame rate, and those two go hand in hand. And the reason for that is we're going to actually control the speed at which the game plays, and we're going to set it to be 60 frames per second no matter what computer you're on. So if you're on a machine that could handle 120 FPS, it's not going to go above 60 FPS. We're going to use this clock to handle that. And then something else, any game that you're going to have that's going to have some text in it, you have to set up a font right in the beginning. And we could go just start making the game and then set these things later, but it's kind of annoying to have to go and do something as basic as like defining a font once you're really into writing the code. So a font is any TTF file. You can drop one in your game if you have a specific font you want your text to use. I use Free Sans Bold in a lot of the tutorials because it's built in. Okay, so let's get to the actual game loop, which we'll just create a variable. We'll set it equal to true. and then we'll say while running. So now we're doing what I always call the main game loop, and this is essentially you set up a variable called running, and anytime that's running, all of this stuff happens every scan of the machine. So these are things like controlling player action and drawing items onto the screen, drawing the screen itself. You want all of that inside this main game loop. So you initialize variables outside of the game loop. You can define functions outside of the game loop, but everything that's actively happening during the game needs to happen in here. And so the first thing we'll do, this is how we control the frame rate, is timer.tick FPS. And then we'll do screen.fill. And this is something I like to do. I like to create a color that I call background, and I give it an RGB value, but just understand you could just type right in these parentheses 128, 128, 128 and give it an RGB. I find it a little easier to just have variables for it, so that's background. And then like definitely in the game, we're gonna want like white and black. So white is all the color, it's 255, 255, 255. And black is absence of color as far as computers care. So that's 000. Okay, and let's go ahead and just do what we need to do to get the screen popping up here, and then we'll start handling like actually drawing things onto the screen. So to do that, after we have screen.fill at the background and timer.tick at the FPS, I set up what's called event handling. And it's essentially for event in PyGame .event .get, and then if event .type is equal to PyGame .quit, and if that's true, then we're just going to set running equal to false. And the reason you always need to have this in here, always, 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 or something very similar to this, is you have what's called an infinite loop without this condition. You have a variable that we set equal to true, and then a loop that's going to run while that variable is true. And if it's impossible to ever set it equal to false somewhere inside that loop, or even in the outside world, if as far as this program knows, it's never going to get set to false, that's an infinite loop. It's going to tank your machine or basically throw an error message immediately. Okay. So the last thing I think we need to do is just to get the screen up here is pygame.display.flip, and it's just called flip because if you know why, actually, I guess you can tell me in the comments, but it just is. Okay, so let me see. Did I get indentation wrong? Running equals false. If event.type is pygame.quit. I don't think there's actually an error here. Let's run that. Oh, it's, my following statement was at the wrong level of indentation. That'll happen. Okay. So when I run it, all right, now we get this gray screen. There's nothing special about it, but at least we open it up, we see we have Yahtzee on the top, and we have our background color. So if you're more of a design oriented person, you can start playing around with that RGB background and change it for a screen that you like. This is a tutorial, and I'm gonna keep it fairly basic, and we're gonna go with like gray, black, and white, that kind of thing. The next thing I think I'm going to do is I'm going to draw the dice onto the screen, but I want these dice to all act the same. And if you're moderately familiar with Python, then hopefully, or object-oriented programming of any kind, hopefully you're fairly familiar with defining classes. And so what we're going to do, and if you're not familiar, that's fine, we'll go over it here. We're going to create a class for the dice. So to do that, you say class and then whatever you want the name of your class to be. And just class is super brief crash course on them here. It's just a way of saying I'm going to have this object and I'm going to have several of the objects and they're all going to behave similarly. So I'm going to group all of the code together for those objects. And the biggest difference between like a function and a class is that a class can have functions inside of it, and a class is really more of an object, while a function is more of a routine that's supposed to affect things. So that's how I think of it anyways. There might be more elegant explanations, but I like that. Okay, so when you do a class, when you create a class, you always want to put this init function or initialize function in. It's def underscore underscore init underscore underscore. And it's going to auto-populate with self, depending on what kind of IDE you're using, but most of them will auto-populate with self. Always leave that there. Just basically saying it's referencing this instance of the class. It's referencing itself. And then some variables that we're going to want to give every die. And in this case, I want to give them an X location and a Y location. And then I want to give each die a number. So the number of I don't know what they're called, pips maybe, the number of dots that are on it. So if I give a die a 2, I want it to be drawn to actually look like there's 2 numbers on there. And then I'll give it what I'll call a key, but since ultimately we're going to use these like a list of dice, they're going to go 1, 2, 3, 4, and 5. So we'll use those later. But the next thing you want to do is you want to take each of those variables that you're passing in from the outside world, and you want to reassign it basically to a self-dot version of that variable. So instead of using just xpos and ypos throughout, use self.xpos, self.ypos, self.number, I'll set equal to num, and then self.key will set equal to key. And let's start building this thing out. So first thing is I'm going to create a function that we'll call draw. And so here's where, if you have done a little bit of PyGame, you're probably familiar with like pygame.draw.rect, and you have to do that to actually get the rectangle to display on screen. Well, I want to just write the code once that's going to draw my dice 5 times, and all I have to do is give them a different X and Y position, and then also tell them how many dots are on it. So how do we do that? Let's use another variable called self.die, and I'm not saying die like attack someone. It's singular for dice. Hopefully you know that. Okay, so and it's going to be set equal to pygame.draw.rect, and we're going to put it on the screen, and then we'll give it a color. I think I'd like it to be white. Yeah, I think that's standard, right? You make white dice with black dots on them. I mean, that's another thing. You could get stylistic with it if you want. That's kind of one of the most common enhancements to games that people make is adding like skins and stuff. So you could make it customizable as well. Okay, and then we have to give it the 4 arguments that a rectangle takes, and that's X and Y start position. And so for that, we'll say self.xpos, self.ypos, and then just width and height. And when I was playing around with this, I liked the look of 100 by 100 square dies. And I liked them being solid, and I gave them a rounded edge of 5 each. So this looked pretty good to me, but once we run it and you see what they look like, you can go ahead and modify them if you want a different look to it. But okay, kind of the trickier thing here is actually based on the number, what we're going to do with the dots that go on the face of each die. Because if you think about a 6-sided die, it actually doesn't go in a necessarily like algorithmic order. There's not really an easy way to set up a function that's going to take the number it was given and draw the right die or the right dots. So what we kind of have to do is just do it manually. And so let's follow along and then we'll talk about it. So for one, we're going to put it on the screen. We're going to make the circle black. And then all you need for a circle, you don't need the 4 arguments like a rectangle takes. You need to give it an X and Y coordinate for the center. And so we'll use the X pause and Y pause, but we know that they're going to be a 100 by 100 die. And so if you made yours a different size, just make sure you put this at the middle. So that's the center of it, and then we give it a radius, and I'll just give it a radius of 10. It looks good. It takes up about the right amount of space on the face of the die. But here's where we have to start doing some thinking, because it's not all as simple as the 1 is, unfortunately. So for the 2, we're going to take this, and what we have to do, if you need to, you can look at like an actual face of a die for reference, but what I'm going to do is I'm going to say we have 1 at the top left. So I'm going to move it back some and up some, and 20 and 80 looks pretty good. And then we are going to have 1 at the bottom right. So what I'm doing is I'm saying when it's over on the left side, use 20. When it's over on the right side, you use 80 for your X position, and then the same for your Y position. And then when it's right in the center, use 50 and 50. Okay? And so actually from those coordinates that we just set and we just picked, we can go through and we can add it to all of them. So we can go through 3 through 5. This is a great exercise if you are following along line by line and you would like to go ahead and do the rest of the numbers. And then you can always come back and watch this part of the video if you got stuck. But I think that you could absolutely figure this one out if you wanted to. And so actually what I'm realizing is top left is going to be 20-20, and bottom right is going to be 80-80. 20-80 would have been top right and bottom right. That would have looked pretty goofy. So, okay, so 20, 50, 80 for the 3s, and that's going to give us like the diagonal across the screen. Oop, goofed something up. Okay. Now we'll do 4, and 4 is going to be top left, top right, bottom left, bottom right. So let's see if I can do this without screwing up. So 20-20, 20-80, 80-80, and 80-20. Okay. And it definitely couldn't hurt. I do this in my notebooks a lot. If you're planning an app and you want to actually like write it down with some directions to yourself almost and say like, okay, remember I need this, I need this, I need this, as well as approximate positions, that could just help you not forget stuff. But we are just going to soldier on. Okay, so 1, 2, 3, 4, 5, and 6. And 6 is basically 3 down the left side at 20 and 3 down the right side at 80. And they're going to go, and we're going to put them at 80, 50, and 20. So that should do it. 20, 20, 20, 50, 20, 80. And then 80, 20, 80, 50, 80, 80. Okay, that's pretty sweet. Alrighty. And I think for now, that'll do it. So sorry that was kind of confusing the way we had to do all this work before we could see any dice. But what we'll see now is I can really quickly create all 5 of the dice. So what I can do is I can come down here and I can say die 1 is equal to dice. And then I can give it all of the stuff that we just defined in our class. So now I can go really quickly through all 5, and I can just say X position for the first one. We'll put it in the top left of the screen, 10, 5. And then right now for numbers, I'm just going to give them a number because we're not yet rolling the dice. Right now we're just trying to see that everything we did works. Okay, so then I'm going to do die 2, and because these are 100 wide and I don't want them to be touching, I'm going to space them out by 120, but then I'll give this guy number 4, and remember this last variable is key, so eventually, this was a little bit of forward thinking, but eventually we're going to be looking some of this stuff up from a list. And so I want to be able to say like, okay, well, that was the first die, that was the second die, that was the third die. And so what I'm doing in this last is I'm just saying if it were in a list, what would its index be? And we're going to use that a little bit later, but I didn't want to not explain why I put that in there. Okay, so I'm just kind of going through and I'm putting them all at the same Y height. You could definitely, if you wanted to, you could definitely stack them vertically if you want, but I think it would look good horizontal. So if you're following along, let's just do them horizontally, spaced out by 120. I just chose to give them all different dice values here, stuff you'd see on a die. So hopefully when we run this, we're going to see all 5 of our dice right there on the top of the screen with different numbers on them. Now, this is just creating them. So this is basically calling an instance of a class is what it's called, but we need to actually get them all on the screen, and that means we have to do all of them using the draw function that we made. So die 3, draw, but you can see I'm using PyCharm, the IDE, but whatever you're using, if you type in the class, as long as you defined it right up here, once you hit dot, all the functions that you put in that class are going to appear because it knows, okay, I'm this class, I have these functions available to me. So now if I run this, I'm really hoping, there you go, we get 5 dice across the top of the screen. How cool is that? So I think that's just super useful, super cool. It does pretty much fill the screen, but that's kind of the idea. I mean, the main thing in Yahtzee is rolling of the dice. So, okay, let's move on. Those are fixed numbers right now, and a big thing in Yahtzee is actually, rolling the dice, getting a new number. So let's put in the roll function. And to start, I'm going to come up here and I'm going to make a numbers list, and I'm going to just give it 5 values, and I'm going to make them all zeros right now. And what's kind of cool is because in our draw function, 0 isn't even covered. They'll be blank when I run this. So if I were to come down here and replace all of their numbers with their key in the numbers function, here we go. Numbers there, numbers there, numbers there. 1, 2, 3, 4. And now if I show you this real quick, we just get blank dice because we didn't tell it what to do. We didn't tell it to handle a 0, and that's actually good. So between turns, when nothing's been done yet, we're going to have them draw a 0 onto the screen, or we're going to have them just stay blank to let you know a turn hasn't really started. Okay, so to actually handle rolling, let's put a button on the screen. And I wish there was a built-in PyGame button. It would be sweet if there was, but there's not. So to do a button, we have to create a rectangle, create the condition for when the player clicks on the rectangle, and if we want there to be some text on or above the rectangle, we have to add that separately. Okay, so we're going to do that. And let's just go ahead and above the dice, actually, let's just say button. Now let's call it roll button. That's another thing. I just like to use descriptive variable names, but they can be a little bit longer. So if you're the sort of person who just has to be efficient and use as few letters as possible, you could literally just call that R if you wanted. But I'm going to say roll button, pygame.draw.rect, just like before. And we'll put it on the screen. We'll make this one black because the gray background and the dice are all white. So let's make it a little different. And let's put it at 10, so that's pretty far to the left, and 160 should put it just a little under the dice, and we'll make it just fairly wide, 280, and then we'll go with 30 for height. So hopefully that's going to look kind of like a button. Yeah, I'm good with that. It obviously doesn't say anything right now, so what we have to do to get text to display is we have to do the 2-step kind of font definition that I had talked about before. So let's go ahead and right here we'll say roll text, and this is going to be equal to excuse me, font.render, and then you give it the text that you want it to be. So just we'll actually say click to roll. We made a pretty wide button. I think that'll look good. And then there's this anti-alias thing. I just always put true. I don't actually know what happens if you put false. Again, if someone knows and wants to tell me in the comments, sweet, go ahead. Doesn't really matter to me. And then we'll make the text white. So I was going to type it out, but we'll make the text white because it's going to be on top of the black background. But then the second step of drawing text is doing screen.blit and then telling it what to write. So it's screen.blit and then roll text, scroll text, roll text, and then you give it an X and Y coordinate. And in this case, we put this guy, what, at 10, 160? So we'll go like 15, scoot it right a little bit, and 165, scoot it down a little bit. And that's actually all we have to do. So let's go ahead. There we go. Click to roll. Here's where, if you're a perfectionist, maybe you scoot this around a few pixels. Maybe you scoot that to the right a little bit. Try to get it more centered. I guess I'm doing it right now. Didn't think I was gonna. I'll scoot it back a little. Okay. All right. No more watching me mess around. We're going to say that's good enough for now. So cool. It says click to roll, but clicking it doesn't do anything. So now we come down into our event handling area, and we're going to make it to where if the player does click on that button, then we're going to actually roll the numbers. We're going to generate new numbers. Okay. So what we do is, instead of if event.type equals pygame.quit, we do if event dot type is equal to, and this is going to be pygame dot mouse button down. Okay, so that's basically a click. And if you wanted to make it on when the player releases from the button, you could do mouse button up. But I'm going to do mouse button down. That's good for me. And we're going to add a whole bunch of stuff to this eventually, because most of Yahtzee on a computer is played by clicking on stuff. But for now, all we need is if roll button dot, and there's this nice built-in function using PyGame, collide point, and all you have to do is give it an X and Y coordinate to check if that collides with the rectangle. And since we're checking to see where we clicked, there's this nice built-in coordinates of event.pause. So event.pause is the position at which the click happened. So it's an X coordinate and a Y coordinate. And when you use a rectangle with the collide point function, that's exactly what it needs, is an X coordinate and a Y coordinate to check if it collides. So what we're saying here is, if I clicked on the roll button, what do we want to do? And all I'm going to do is, for now, I'm just going to say roll equals true. This will also be where we handle later. So we have to create a function called, or a variable called roll right up in the beginning. And all I'm going to do is just say roll equals true, but later we'll also like subtract 1 from the total rolls you have left, because you obviously can't just roll forever in Yahtzee. Okay, so now what we'll actually do so we'll say if roll, and this is how I create what I like to call like self-sealing code. So if roll is true, well, at the end of doing this code, we're going to set roll back equal to false. So once you click on this, it's going to just roll once, and then it's going to immediately unlatch itself in that same code. But what I want to do is say for number in, and then for range, we'll make it the length of our numbers list. So it would be pretty easy to just say for I in range 5, because we know there's 5 dice. But technically, this would be able to handle it if there were more or less dice. And then what we want to do is just say numbers at the number value is going to be equal to, and here's where that random module that we imported is super useful. There's this built-in randint function that's going to select a random integer 1 through 6 and stick it in our numbers. Okay, so this should let us now, let me just go ahead and run it. Click to roll. And there we go. We get 55136, 41412, 16453. See, so you can tell we're getting random numbers every time I click this, and it's pretty sweet. You know, you can't play Yahtzee yet, but this is pretty cool. We've got this rolling, dice game. So that's pretty good. I think the next thing we should do is we should get kind of the scorecard, or I guess game board it would be considered. Let's get that on the screen, because that's going to be the other big piece of this game. Isn't just rolling dice, it's also deciding what to do once you have those dice rolled. And to do that, we're going to need to create another class. So just like dice had a class, we're going to make a class that I'm going to call choice or option. Call it whatever makes sense to you, but I am going to call it choice. And again, I'm going to initialize it, _init. But if you're familiar with Yahtzee, you should know these are things like use your 1s, use your 2s, use your 4s, use your 6s, use the small straight, use the large straight, anything like that. And so we're going to draw those on the screen, and what that means is we're going to have to give it an X position and a Y position, just like we did with dice. But we're going to give these a few extra things. We're going to give them text because every one of those lines has to have text on it. And then we'll give it a variable saying whether or not it's been selected, right? Because you have to choose in Yahtzee where to use your turn. And so I'll call that variable select. But then we also want to give it a variable saying whether or not it's possible. So this is basically saying like you can't select large straight if you don't have a large straight, or at least if you do, it's going to give you a 0 for your score. So we want that variable as well. And then we'll want a variable saying whether it's already been used or not, because another thing in Yahtzee is you can't go and put, values in for your 2s twice or 3 times. You can only do it once. So we'll use that variable as well. And I think to set this up, that's all we'll need to do. So again, just really quickly, I'm going to map all of those variables, X pause, Y pause. I'm going to map them all onto a self dot variable of the same name, and then self dot text we will call text. Getting super creative with the names here. Self dot select equals select. Self dot possible equals possible, and you guessed it, self dot done is equal to spaghetti. Nope, it's done. Okay. So for drawing this, just like we did on the dice, all we have to do is self.draw, and then actually, I forgot, make sure you get your indentation correct. These should both be inside the class. Make sure you don't goof it up. But then the drawing, you don't have to pass in any additional variables because it thinks we do. Indent expected. Class. Class is not capitalized. Okay, stupid. Little silly format things. Still get seasoned Python veterans, so don't worry if you goof up sometimes. Okay, so to draw myself, I guess, per line, let's start by just kind of outlining where it is. So it's going to be pygame.draw.line, and then let's put it on the screen at, let's make it a black line, and let's put self.x pause, self.y pause, and I think also let's put one maybe 30. 30 was a good spacing when we had these in. So let's, after we do this first line, let's do a second line that's 30 down as well. So for a line, this is a new thing we haven't drawn yet in PyGame. It takes an X and Y position for a starting coordinate, and then it takes a X and Y position for an ending coordinate. And so in this case, I want a horizontal line at the top, and I want a horizontal line at the bottom, just kind of framing in where each thing is. And then you give it a line width, and we'll say 2. And then I'm going to make another one of these, and I'm going to put it, self.x pause. Yeah, I'm going to put it 30 down. 30. And once we make all our classes, we can modify this really quickly if we need to. But I think this way we're going to have 30 pixels to really frame the text that we're putting in. Okay, so now let's go ahead and do font.render. Font.render, and the easy part here is just self.text. Instead of having to put in the text, we are going to pass the text in as a variable. And so all we have to do there is self.text and then true. And we will make this different colors based on if it's selected and if it's possible. But right now, let me just say true so that we can figure out where's a good place to put it on the screen. And so I'll say my text is equal to font.render because we need to use it in the next part when we do screen.blit my text. And where I think a good position for it would be self.xpos. And I know we're going to want to move it a little bit, I think, to the right, maybe to the left. So let's just see self.xpos, self.ypos just to get us started. But I think that we want to move it down and we want to move it right. So let's go ahead and do ypos plus 10, just scoot it a little ways down, and xpos just 5 to get it off the left side of the screen. And let's just leave it at that for the moment, and let's make one of these. So we're not going to make all of them just yet, but like the first choice on a scorecard, I believe, is the ones. So we'll do ones equals choice, and then it's going to need all of its parameters that we defined in here. So we want this to be underneath the dice and the rolling button that we had before. So I think what we should do, we'll start it at the very left. So this is going to be kind of its zone, and it's going to go from 0, and then the Y position, we'll put it at 200. So that'll be below the buttons. For text, we'll just say ones like that, because it doesn't take up too much space. And then for, let's see, I think for now, because the next variables are like, is it selected? Is it possible? Is it done? I'll just say, yes, it's selected. Yes, it's possible. And no, it's not done. And ultimately, these are all going to be coming from lists, just like the number variables. But I'm trying to get one on screen real quick, just so I can make sure what we're doing looks good. Don't even take my own advice. So we made it, but we also have to call it. We have to say ones.draw, just like that. So now, there we go. We get ones, and we get kind of these rectangles just showing us where like the ones space is. And I think that works. And the reason I'm not putting like horizontal like color in it yet or vertical lines is because I want to create a function to draw a lot of stuff that's static on the game board and not changing it separately. I'm going to call it like draw stuff, but I want to get these choices ironed out first. So let's do a few things based on if it's possible, if it's done, if it's true, things like that. So we're going to go back into our choices class. And I think what we'll do is we'll say, okay, yes, draw these two lines first. But then we'll say, if not, self.done. So this means it hasn't already been finished. If it is finished, we'll just make it black and not colorful. And then we'll say, if self.possible. And so now we're saying like, okay, it would be a good time to select that one. So like you actually had a full house and you wanted to select full house, or you actually had a large straight and you wanted to select large straight. So if it's possible, then we'll say my text is equal to, and I'm going to take this whole line here, Control C. And instead of making it black, the only difference is I want to make this one green. And I'd like it to be like a forest green. So I got this RGB value that I think looks pretty good. If you want to follow along exactly, feel free to use it. If you want to pull your own like green RGB value or whatever, go ahead. But then I'm going to say, okay, and then if it's not possible, so elif not self.possible, and I want to use like a red, but when I was playing around with this, just bright straight red looked pretty good. So we'll just do 25500, and again, you could put these in variables. I definitely did that for white and black, and that looks pretty good. So just go ahead and do that. And then what else I'll do is say just else. So this is for the original done condition. And now I'm saying, okay, if it's not done, then make it green or red depending on whether or not it's possible. But if it is done, just go ahead and make it black, and then draw it on the screen. And so that should be pretty cool. Just with this, I think we can play around now and actually, yeah, so you can see it's green because I have it just hard-coded as possible. Now let's see if I change, I think this was done. If I change it to done, it's black. Okay. So I'll change done back to false. And then I think this one's possible. We'll do false there, and that should be red. Yep. And so that looks pretty good. I'm happy with that, but I'm going to go ahead and make all of these choices, and then we're going to talk through the kind of like static drawing thing that I had mentioned before. I just wanted to actually get into writing some of the code before just drawing stuff together for too long. So the next thing is going to be, we're going to instantiate or create an instance of each of these choices. And actually the super nice thing is the way we wrote that is such that we can use what we just created to also do the score keeping pieces. So if you pull up like a Yahtzee scorecard, you'll see a whole bunch of things that are approximately the size of one of these options, but they're not options, they're score totals. So like your total of the upper section, your total of the lower section, getting a Yahtzee bonus, they're all on there. And they're about the size and they're in the location of these, but you can't like select them. Well, that's really easy. All we're going to do is we're just going to modify a few of their inputs so they can't be selected, okay? And so what we're going to do is, just like we made ones at 0 to 100, we're going to start making all of these, and we're just going to scoot them down 30 pixels per case. And you can play around with the spacing if you want. But I just like how they looked, about 30 apart. And then, okay, we'll say 1, 2, 3, 4, 5, 6. And then we're going to have these 3 that are really more totals. So it's going to be lower total 1. And if you don't know where I'm coming from with these, lower bonus. Or actually, I guess this is upper total, huh? Interesting. Upper total 1, upper bonus, and this one will be upper total 2. Okay, if you don't know where I'm coming from with these, then just look up Yahtzee scorecard, because we're basically trying to remake it perfectly. All right, so we'll put them 30 apart, and then for the text, we'll say upper score, and then this one is going to be bonus if greater than or equal to, I think the value is 63, and then this one will be total upper score. That might be too long. We'll say upper, yeah, we'll just say upper total, because upper score is different enough. Now what we can do, and I was talking about this a little bit, is for these we're going to take some of their values and we're just going to change these things around. So like false, because it'll never be an option. So that first one, like, is it enabled, is it possible, we'll just put it in as false. No, it's never going to be possible. And then we'll do the same thing for the second one. So if you remember, these 3 were, here, I'll go ahead and have it pop up. These were, is it selected? We don't want you to be able to select any of them. Is it possible? And then, is it done? And so what we'll say is like, well, it's not possible, it's not selectable, and it's done. So we'll just hard code those 3. And when I do come back and I replace all of these with variables, we're not going to replace these with variables. And that's how we get this. I'll just go ahead and show. So we have to do all of the draws as well. So 2's dot draw, 3's dot draw, 4's dot draw, 5's dot draw, almost there, 6's dot draw, and even the options, upper total 1 dot draw, upper bonus dot draw, and upper total 2 dot draw. Okay, so now I'll go ahead and run this, and you'll see they're all red because I left enabled or option possible. I left them all as false for now, but we're going to replace them with variables in a second, so that doesn't matter. But you can see the 3 that are just totals are in here, and they look pretty good just in black. So let's go ahead and just finish the rest of the options. This bit's a little bit painful, so if you need to skip through and you just want to like grab the Python file from GitHub and copy this part, you totally can, but it's not a bad idea to know what you're putting in. So the next one's going to be 3 of a kind, and then the next one is 4 of a kind, and then the next one is full house, and after that is small straight, and then large straight, and then you have Yahtzee, and there's actually more options on the bottom half than the top half. There is also your chance, which is like just whatever cards or whatever the face of the dice are currently showing. And then you also have this like bonus Yahtzee. So it's I'm just gonna call it bonus, but that's actually going to get the treatment. The bonus is going to get the same treatment as the totals because the player doesn't really select that. We tell them when they can have a bonus. Okay, so for the text, we'll say 3 of a kind. We'll say 4 of a kind. 4 of kind, good enough. Full house. Small straight. Small straight, large straight. Yahtzee will be Yahtzee, and that's the name of the game. So we will make it all caps and give an exclamation mark because that's cool. And then chance, and then this one is going to be bonus Yahtzee, or I think it's called Yahtzee bonus. And then we have, just like these were upper total 1, 2, this is going to be lower total. And then actually this one is, it's kind of upper total 3. So I'll just call it lower total 2. But what's annoying is the scorecard just kind of shows your upper total in 2 places, so it's gonna be, and you'll see when we put the values in, it's gonna be exactly the same as upper total 2, but don't worry about that right now. It's a little silly, but that's how the game put it up, because the typically a person would have to do this math by themselves, but we're gonna make our program do it. But you have this grand total at the very end that says what your actual final round score is, so how well you did total. And we need to make sure we continue this spacing every 30. So there's 470, 500, 530, 560, 560, 590, 620. Getting pretty good at adding 30 to numbers. 650, 680, 710, 740. And 770. So here is why I made the screen 800 high, because it looks pretty good like that. So let's go ahead and get everything else drawn on now. We have all of them made, so we just need to get the rest of them drawn, and we have 3 of a kind dot draw, 4 of a kind dot draw. So this may seem tedious, but compared to having to write all of the code that we did for each of these choices, every single choice, this is not even close to tedious. This is so time saving. So full house dot draw, small straight dot draw, large straight dot draw. Next is Yahtzee dot draw, and we're just getting them all on screen. And the nice thing is now, if we add stuff, which we will be doing, to each choice to get it to display like how many points are currently in each spot, all we have to do is modify the draw function once, and everything else is already in place. So this is really great. So lower total dot draw, and then lower total 2 dot draw. It's cool that I didn't use a constant naming convention. I'm gonna rename this to lower total 1, just because that's what I did for upper total, and I try to be moderately consistent. And then grand total dot draw, and let's see, I am positive. Yes, I did. Bonus dot draw. I was gonna say I'm positive I forgot something, but I caught it right away. Okay, let's see. So I left all of the ones that you will be able to select as red, just so that we can find them easier. But you can see the ones you can't edit are still in there as black, and so this is great. We just made like the whole scorecard, and all we really had to do was write the code to draw that stuff once, and then we just had to kind of give it some parameters for each line item. So this is what I talked about before. We're going to make that scoreboard look a little better. We're going to make the dice rolling area look a little bit better. And this, I think, is really important to making it just look good and feel like a better game. So let's go ahead and quick water break. I'm doing a lot of talking. You guys aren't contributing any to this conversation. Okay, so I'm going to come down where I'm drawing everything. Sorry, not trying to throw shade. And right underneath all of those where we called them, actually, I'll come up a little bit higher even. And right where we're drawing this like first button, I'm just going to create a function. I'm going to call it draw stuff. And I don't have to give it any parameters because we're going to define everything right in here. I just want to take it out of the main game loop. You could put all of this code that we're about to put right here. You could put all of that right in the game loop where I put this function draw stuff. I just like to pull out kind of separate functionality, and actually even the like roll text I'm gonna take up there. Actually, shoot, same with this blit. Just because this game loop is going to be so full of just defining things and calling things that we need to have in there, that putting just all this static drawing and text up into a function is going to be a better place to put it. So we've got the roll text. Let's go ahead and make a second button that will be like accept a turn. We won't have it do anything yet. So the button I'm going to actually call in the game loop, because that's going to make it easier to check if it was pressed. So the first one we put at 10. This second one will move far enough right that it won't be like overlapping. And I think around 310 will be pretty good for that. So we'll try that because it's 280 wide. We just want a little bit of a gap. Okay. Now we're going to take this text and I'm just going to poach it, and we're going to make some accept text. Accept text. And then down here we'll also make it accept text. And this will say accept turn. So we'll make this be how you actually submit a turn. Once you've rolled as many times as you want and you've selected like where you want to score your current score, we'll click this button. So that'll be the first thing we put in the accept turn. And then let's introduce a new variable that we'll call rolls left. So in every turn of Yahtzee, you can roll all of your dice or some of your dice up to 3 times total. We'll make this variable called rolls left, and we'll also show that on the screen. So screen.blit for that text. And then this is going to be rolls text. That's what I'll call it. And it's going to be font.render. And all we have to say is rolls left this turn, and then I'm going to do this concatenation, which is a plus and then str, and then I'm going to just display the rolls left variable. And so to do that, you can just call it if you don't want to pass it in, or you can pass it in as a variable. And some IDEs, sometimes you might not have to do that. It's just good practice to have your variable available right where you want it. Okay, and then true, and then we'll just make this white because it's going right on the gray background. And let's see if that's enough. Oh, I didn't blit it. Stupid. Don't even take my own advice. Screen.blit and roles text. And we'll put this one at 1515. So right in the 155. Right in the top right of the screen. Let's go ahead and see. Rolls left this turn. Oh, I didn't move the I didn't move the text here over by 290. So that'd be what, 375? Bam, good enough. Okay. So we're drawing the roles text onto the screen, and then we'll also go ahead and draw some of the constants that we want to like fill in the background area. So pygame.draw.rect, we'll put it on the screen, we'll make it black, and this is going to be kind of an outline of the rolling area. So for the 4 arguments, I'm going to start it at 0, 200, and then I will make it 225 wide, just like we made those buttons. And then I will make it as tall as the screen minus 200. So that's where it's starting. And I'll show you why I did that. Because I wanted this space to have a background. Okay, but obviously that like death black doesn't look that good. So I think what we should do is we should make that a hollow rectangle. No, let's go ahead and keep it like that. Let's go ahead and keep it like that for now, and we'll see as we get into it. I think there's some ways we can make things look a little better, give some contrast in there. But next, I think we should draw some lines to kind of divide up the space. So we'll go make it the whole width of the screen, and we'll make this one white. Or I'm sorry, let's make this line black, and let's make the background white. I don't know why I would draw a bunch of white lines on a black background. Black, yeah, I didn't finish this yet. I'm going to cancel this. I think a white rectangle is just going to look much better. Yeah, that looks way better. Okay, that was goofy. And then I think I made those lines 225 wide, not 255. All right, sorry about that. It's a long video. So we're going to draw some lines now, some just constant lines to separate up important parts of the screen. And I'm going to put this first one at 0.40 to kind of separate like instructions area from the actual dice. And it's going to go to the width of the screen and then stay at 40. So it's just a horizontal line of thickness 3. And I'll show you what that looks like. There you go. So I like that. I think it splits up the top from the bottom of the screen. And now I'm going to put another one like that just under the buttons. So let's go ahead and copy that a couple times here. I'm going to do this second one, I think at 200. And then we will go ahead for the third one. I don't think we need another vertical like that unless we go with 600, 0 to 200. Let's stop there. Let's take a look at what that looks like. Yeah, that's pretty good. Okay, now let's do a vertical line to split like the text that we put in from where the scoring is going to be done. I think that's a pretty important one here to really divide the different areas of the, I guess, the map up. So let's go ahead and do pygame.draw.line, and this we'll put on the screen. We'll make it black, and we are going to start it at where we started the where we started the game choices section. We called it choices, and that's 155 200, and then it'll go all the way down to 155 by the height of the screen. And we're going to do 2 of these because we're going to have to scoot the second one out to 225 where it ends. But what this should give us hopefully is a nice rectangular scoring area. And we didn't give those guys width, so they looked really thin. Let's go ahead and do 3s for all of them. Give ourselves some good stuff there. Okay. And I think that looks pretty good. We could put scoring in there for sure. We can still roll, but it's not de-incrementing the rolls left variable. So let's go ahead and get back into writing code. But now if we decide to put any like just static stuff on the screen, I'm going to add it to this draw stuff function rather than put it in my main game loop. So I'm glad we set that up, but let's move on to the functional stuff. Let's go ahead and de-increment that rolls left variable every time it's clicked. That's just an easy one to add. So if roll, then roll is false, but in our game handling, where'd it go? Here we went. We're only going to let them if you click the roll button and rolls left is greater than 0, then we're going to let you roll, but then we're also going to subtract 1 using this minus equals from the rolls left function. And so now click to roll, click to roll, click to roll, and then I can only roll 3 times. So that's awesome. For testing, that only being able to roll 3 times when I boot up is going to get old fast. So I'm going to make it a 10, but then once the game is fully ready to play, we'll get back into 3. Okay, so there we go. I got 10 rolls every time we start up. All right, let's do some super important stuff. So I kept saying we're going to change all these out for lists. We're going to change all these out for variables. Let's go ahead and get started on that. So we kind of talked about it. There are going to be 3 pretty important lists in every choice. There's going to be if it's selected, if it's possible, and if it's done. So to do that, we're going to create 3 lists just like we did with the numbers, and we'll call them selected, possible, and done. Okay, because I'm not that creative. And let's go ahead and say we'll actually call this selected choice because we're going to select the dice as well, and I don't want to get too confusing later on. So we'll say selected choice, and here's where we have 13 choices. If you want to go back in there and count, you can, but we have 13 choices, and so we need 13 falses. Just copy that a whole bunch of times. We've got 4, 5, 6, 7, 8, 9, 10, 11, 12. Whoop. Somehow I messed up. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I started counting from 0 because that's how the code works, but you just want to go to 13. And now if they're possible, so I'm making them all false to start, obviously, and you can make them true, I guess, if you want, because technically the code that we're going to write is going to handle whether or not it's true or false. But for now, I actually think you should just leave them all as false when we start up, and then we can come down into where we create those instances, and we're going to replace these just trues and falses with our lists that we just made. So this will be selected choice 0. I'm going to do all 3 so that I can kind of copy them as I go through. So it's selected choice 0, and then possible 0, and then the last one will be done 0. But there's good reason we did it this way, and we'll see once we get into it. But I'm just going to come through. That'll be 1s, 2s, 3s, 4s, 5s. And if it just drives you nuts that like these are actual number options, like 1s are 0s and then like 4s are 3s, you could put like nothing but dummy values in like index 0 of your lists, but it's better to just understand why programming starts at 0s and use these, even though I'll admit it's not ideal. And we only have to do these 3 options that we just made for the actual choices, right? So we don't have to do it to the totals. There we go. 5, 6. 6. This is just another one of those somewhat time-consuming things, but trust me, it's nowhere as time-consuming as as writing all of the code that we put inside of the class would be 13 different times. So definitely the right call to go with classes, even though it feels like just going through and changing index values can be kind of a lengthy process. Okay, 10, 10, this will be 11. Gotta give it square brackets. 11, 11, and 12, 12, and 12. Okay, so that's pretty sweet. We can go ahead and boot that up and see what we're getting. Really no change because we haven't put in like the functional code yet, but it is nice to know that now those are in variables, so we can start modifying them in the outside world, and that's exactly what we're going to do. Okay, so the next thing we're going to do is let's go ahead and create a function that I'm going to call check possibilities. Okay, so we have possible list, and we're going to create a function to check whether or not each thing is possibilities. So we're going to check whether or not it's a good time to do each of them. And to do that, all we're going to do is pass in the possible list, and we're going to pass in the numbers list, and everything else we can do inside of the function. So come up where we're creating where we're creating everything, and go with define check possibilities, and make sure you're receiving the two things we passed in, which are the possible list and the numbers list. And the reason I'm adding list here is just to not reuse the same name they have in the outside world. This is a big program, and if you reuse names inside of inside of functions, it can get a little confusing during troubleshooting what's where, what's going on in each place, and why. So we're gonna go ahead and do this. All right, so a few easy ones in the possibilities list are, we're just going to come in here and we're going to do a few of the obvious ones. Like 0 is always going to be true. So 0 through 5, right, are just the numbers. So regardless of how many of that number you have showing on the dice, you can always just pencil it in as your 1s through 6s. So technically we could make them false if you had no 1s up or you had no 5s up, but sometimes in Yahtzee it's a strategic move to like put a 0 in for your 1s so that you don't have to lose a Yahtzee. So a part of this game is a part of what we're doing in Python is understanding how Yahtzee works. And if you don't, then just follow along and don't ask questions. But hopefully, if you are familiar with Yahtzee, this will get you thinking about it as well. Okay, and then the next thing is I'm going to create a new variable that I'm going to call max count, and we're going to use this for the next ones. So max count is basically going to be how many of a number do we have. And what I'm going to do is I'm going to say for index in range, and I'll just say 1 through 7 because ranges in for loops for Python are not end inclusive, but they are start inclusive. And that means this for loop is going to use 1, but it's not going to use 7. I don't know why. That's just the way it was written. But so the first value, the first index value in this loop when it's called is going to be a 1, and the last value is going to be a 6. So what we'll say is for that index, if the numbers list, if the numbers list dot count is actually the count index value is going to be index plus 1. Nope, just index. Is greater than the max count. So this count function is a built-in checker of how many times a certain value appears inside of a list. So this is going to go through and see how many times 1 is in your list, how many times 2 is in your list, how many times 3 is in your list, 4 is in your list, blah, blah, blah. It's going to go through for 1 through 6 and do that check. And what we'll do is if that's the new max count, if that's the new largest value, then we're going to set max count equal to nums dot count of whatever that index was. Okay, so we're going to, sorry, nums, it's numbers list. Numbers list. whatever the count at that index is. And so this is great. This is checking to see, okay, how many ones are in there. And if there's 1 in your dice, it's gonna set max count equal to 1. But then if it gets to 4s and you have 3 4s, it's gonna set max count equal to 3. And it's gonna do this every loop. So you don't have to worry about if you roll, it's gonna automatically update. And now we can use that max count value that we just made, and we can do a whole bunch of useful things with some of the other possibilities. So if max count is less than equal to 3, less than 3, not less than or equal, then what we can say is in our possible list, a few things have to be false. 6, which is if you have the list right up next to you, 6 is 3 of a kind, right? And also has to be false is 4 of a kind, because we're saying the max count of any one number wasn't even 3. It was 2 or it was 1. And so 6 and 7 both have to be false, and I'm going to copy these. Another 2 that have to be false are 8, which is full house, and full house is you have 3 of one number and 2 of another. And then also 11, which is Yahtzee, which is 5 of a kind, right? Excuse me. So if max count is less than 3, those things have to be true. And we'll add an elif now. So you can speed up your if statements a little bit by saying elif, basically saying if this one was true, you don't have to worry about anything in here. But now we'll say if it's exactly 3, what additional info does that give us? That tells us that the possible list 7 is going to be false. Oop, that was already in there, which is 4 of a kind, and it's going to tell us for sure that Yahtzee is false because we don't have 5 of a kind. And that's going to mean that we need to check to see if full house is possible or not. So what we'll do is we'll say checker equals false. So this is a new variable I'm making just to check for whether or not we have a full house. And we'll say for index in, and then, so I did it range 1 through 7 up here. But what I'm going to do this time is say for index in range, and this will be through the length of the numbers list. So it's going to go through each value in our numbers list. And if the numbers list dot count of that number, I'll explain this once I get it out. It's kind of confusing to talk and write, but it makes a lot of sense once it's down there, I promise. Okay, so we're going to go through each number in the numbers list if we know that the max count is equal to 3. And if at any point on the numbers list we have a number that does equal 2, the count of it equals 2, that means that you have 3 of one number and 2 of another kind. There's no other way it works. So this is saying if the max count is equal to 3, meaning there's some number in your dice that pops up 3 times, then what we do is we go through each number in the list and we check to see if it pops up twice. And if it does, that means we have a full house. So it might seem a little confusing, but I promise it is not too bad actually. And so what we want to do then is say that the full house is true, and then we'll also set the checker equal to true. So that means that we can be done checking. And now when we exit the for loop, what we say is if not checker. So if at no point while checking we went through and saw that it was true, then we're going to set it back equal to false. So it might seem a little weird to like, okay, it's false, check all these things, only set equal to true if this very specific condition, and then if not checker, set back equal to false. But I promise it works. It's the perfect way to check for a full house. If you do know of a more elegant way and you want to use it, go ahead and do that. Feel free to tell me about it in the comments below. Love seeing what you guys do to make it your own, but this solution actually works really well for me. Okay, so we'll do another elif, and we'll say now if it's exactly equal to 4, then the possibles list is equal to possibles list at spot 11. So that's the Yahtzee is equal to false. And so you can see I came through here and I did a lot of falses and I haven't done a lot of trues yet, right? That's what we're going to do next. Yep. So we're going to come in and say, actually I want to put this above the less than 3. We're going to come in and say if the max count is greater than or equal to 3. Okay. So if it's greater than or equal to 3, then possible list at spot 6 has to be true, because that's checking if we're allowed to do 3 of a kind, or I guess if we have a valid lineup to do 3 of a kind. And then we'll say if max count is greater than or equal to 4, then we're going to go ahead and set possible list at spot 7. What'd I do? Typed 4 instead of an equals. There we go. Then we'll say possible list at spot 7 is true. And then we'll do one more. That's if max count is equal to 5. So that should be the highest, so we don't have to do greater than or equal to 5. Technically, you could do greater than or equal to 5. It'd just be really weird to have 6 dice, but yeah, it doesn't really matter. We'll leave it that way. And then we'll say that means that Yahtzee is true, which is awesome. Okay. So this is how we check for 0, 1, 2, 3, 4, 5, 6, 7, 8, and 11. And I think the only 2 that we still have to check for are going to be 9 and 10, because they're small straight and large straight. And that's actually a little bit different, but not too hard. You can see this check possibilities function is getting pretty long, and that's why you want to put this stuff in function. So if at any point we notice like the animation of the different boxes, the colors aren't working properly, we can come right into here and check all this code that's setting things equal to true and false and back and forth. We can edit it all right in here, which is really useful. Okay, so to do the small straight and large straight, we're going to need to get the highest and lowest values in the list. So to do that, I'm going to make a variable called lowest, and this might seem a little confusing, but I'm actually going to set equal to 0 to start, and I'm going to make a variable called highest. I'm going to set equal to, lowest I'm going to say equal to 10, highest I'm going to say equal to 0, and then what I'm going to do is I'm going to say for index in range length of, and again we're going to do our numbers list. And you need a colon. Everybody needs a colon. Okay, and what we'll say is if the numbers list at the numbers list at the index is less than the lowest, then we want the lowest to be equal to numbers list at the index. And you can be saying like, oh, whatever, that's stupid because it's always going to be lowest. Yeah, for the first number is always going to be lower than 10, and the first number is also always going to be higher than 0. But what this will do is it'll go through the list and it'll do the same for every value. And it's going to go ahead and give us the highest and the lowest value. Okay, so at the end of this little for loop, it's going to tell us the highest and the lowest number in our list. And all we have to do to check if we have essentially a small straight or a large straight, which is a certain number of numbers in sequence, is if, and I'll just use lowest, but you could do the same thing with highest. If lowest plus 1 in numbers list, so this right here, what we just wrote, is going to give us a true false. That's what this in is. It's a function that'll go through, it'll take a value, like in this case lowest plus 1, and it'll check if it's in a list. So as long as lowest plus 1 is in numbers list, this will give us true. And we'll string a bunch of these together. So we already know that lowest is in the list. That's how we got lowest. So what we need to do is we need to check and lowest plus 2 and lowest plus 3 and lowest plus 4. And you can think of all the different ways that you might be able to get a large straight, which is 5 numbers in a row. But the fact is you only have 5 dice, so you're always going to have the lowest value, lowest plus 1, lowest plus 2, plus 3, and plus 4 anytime you have a large straight. And so that's all we have to do to put in here is possible list 10 equals true only when we have all 5 of those values. And then we can add an else statement and just say else possible list 10 equals false. And it's really important you put statements that are going to set stuff back equal to false, because you could think without this little bit of code, which doesn't seem super necessary right at first, once it goes true once, it's going to stay true forever, because the only time we tell it that possible list 10 and all these others is false is at the very beginning. So the odds of you at some point during Yahtzee making something true, but then you roll again and it's no longer true is really likely. So you need to have these false statements to balance your code out. And now I can take this and I can poach it a little bit, but we are going to have to modify it for a small straight, because there's kind of 2 different scenarios for a small straight. So we'll change these to 9s. And what we're going to do, a small straight obviously is just 4 numbers in a row. So if lowest plus, fortunately it's not that hard. If lowest plus 1 plus 2 and plus 3 are all in the list, that means that we have a small straight starting with whatever our smallest value is. So think you have 1, 2, 3, and 4 and a 6. That's not a large straight because you only have 4 in a row, but your lowest does work. And you probably see where we're going with this, and you've probably also noted that we haven't used highest yet. And we can put this on a second line, which we should, just to make it easier. Use this backslash to just be the new line character. And actually it's backwards to do highest. We do highest minus 1, highest minus 2, and highest minus 3. But those are the only 2 ways that you can have a small straight. I'll just give you time to think about that one on your own if you don't believe me. But basically, if you don't have starting with your highest number and then 3 numbers directly below it, or starting with your lowest number and 3 numbers directly above it, you don't have a small straight in Yahtzee. So there you go. Okay, and now we're checking 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. All right, that's awesome. We just made a function that checks if all of them are possible. And so what we should do, if I open this up now, none type object is not subscriptable. Okay, sorry about the confusion. Our issue was we said we wanted to get the possible list back, and we never returned the possible list. So that was my mistake. I forgot to return it, but there we go. So what I'd like to see, I'd like to roll, and let's see, I get 1, 2, 3, I get 2 2s. Let's roll a few times, see if I can get any of these below conditions. 2, 3, 5, 1, 2, 2. Come on, give me something. Okay, it's not behaving. Oh, there we go. We get a small straight. Okay, perfect. 2, 3, 4, 5. I just wanted to see one of them actually trigger. So green is just telling us that it's a good time to use that one if you want to. So you could, this is where I was saying you could make conditions saying if 1 is not in your numbers list, 1 should be red. If 2 is not in your numbers list, 2 should be red. Basically telling you don't use this, you don't have any of them. But I actually think just leaving them green all the time is fine, because you know you can select a number at any time. Technically, you can fill in a 0 for any of these at any time as well. It's just going to give you no points. One key feature of Yahtzee is being able to keep the actual rolls that you want and only re-roll the dice that you don't want. So I think what's important is we add something to select the dice now that you would like to keep in your next roll. And to do that, we are going to make another list. So this is why I called it choice selected initially, because I think we need another list, and we're going to call it dice selected or die selected, something like that. I'll do dice selected because I just feel weird saying die a whole bunch, even though it's what singular for dice. I don't want YouTube to demonetize my already not monetized channel. So I'll just say dice selected, and I'll make it false for everything. And now what we'll do is we'll handle what makes it true. And then if it's true, don't re-roll. So let's go ahead and go down into our game handling. And I think to our dice class, I like this idea. Let's go ahead and draw some indication that you've successfully selected it, because if it only happens behind the scenes, it's not really useful to the player. They're not going to fully understand it or see it. So inside of our dice class, I'm getting turned around in this code. Okay, inside our dice class, let's add a new one, and we'll just call it selected, and we'll say self.selected equals selected. And I don't mind just calling it selected inside the function because it's in the dice module, so obviously we're talking about that. And I'll say if self.selected, meaning someone has chosen you to not be re-rolled, I'm going to take this initial pygame.draw.rect and we're just going to modify it a little bit. Pygame.draw.rect, we'll put it on the screen, but we'll make this one red. And I didn't make that color initially. You could if you want. I'm just going to say 25500. And now instead of it being solid, I'm going to just make it, I'm just going to make it 4. And I actually think because we have to check if every die gets clicked on or not, I want to add a function in here that I'm going to call check click. Def check click. And it's going to be at position self, and we need to pass in some coordinates, which will be the actual click of the mouse. And all I'll say is if self.die.collide point, and let me make sure that's what I called it. Yep, self.die collide point with coordinates. Then what I want to do is say if I'm selected and I think we should probably pass in the whole, actually don't know if we need to pass in selected because then we're gonna have to modify every die. What we could do is get the global dice selected list, and we can say self.selected equals dice selected at key. So that's how we can kind of leverage what we've already written. I like not having to go through all of my instances of classes and modify them if I can avoid it. So we'll do it that way. And we'll say if self.selected and I get clicked, then I want to turn it off. Yeah, okay. I was getting so confused for a second. So if self.selected, then self.selected equals false. And let's see, we may have to edit if elif not self.selected, self.selected equals true. And I'm going to do one more thing just for testing. I'm going to print the dice selected list whenever I send something to be true. So let's check this out. Roll, and let's say I want to keep my 4s. Yeah, that's not working. All right. So what I think we should do is instead of if self.selected, we do if dice selected at self.key. Oh, it's also not working because I'm so stupid. It's also not working because we didn't call this or passing coordinates yet. Sorry, it's a long video, bound to make some mistakes at some point, but we'll do it this way. We'll say if the rectangle that makes up that die has been clicked on, then we're going to just toggle this rectangle on and off that says whether or not you've clicked on me. And so the other piece of that now is we just need to, and did I call that check click? I did. Okay, good. All right, so now in our game loop, we're going to go to where we had mouse button down. And remember I said there's going to be a lot of stuff in there. So if event.type is equal to mouse button down, we will say die1 dot check click. Gotta be able to type. Die1 dot check click, die2 dot check click, we'll do die 3, check click. Die 4, check click. And die 5 dot check click. So there we go. All right, and now I'm hoping that's all we have to do to, I'm sorry, we have to pass in the coordinates as well. Put the cart before the horse. Just gonna get an error if you don't add these. And now let's see, I'm gonna roll. I'm gonna say I wanna keep my 4s, and I'm gonna roll again, and it's gonna change them because we haven't told them what to do yet. But I can at least turn these rectangles on and off. Okay, sweet. But what we gotta do now is in our if roll statement, we need to say for number in range length of numbers, and then we need to add a condition that's if not dice selected at, and then number. Number. There we go. So if it's not selected to be kept, then we want to roll again. And no matter what, we still want roll to be say equal to false after roll is active. So let's try that. Roll. Let's keep our 6s. And we'll keep another 6. And we'll keep another 6. And you can see if you're following the whole screen, we got 3 of a kind and 4 of a kind when we had enough 6s to get 4 of a kind. So now I'm going to get rid of that 6. And let's see. I actually got a full house, and we got full house. Okay. How sweet is that? Now I guess we could try to get some kind of straight. 3, 4, 5, 6. And we got small straight. Okay, it's like the dice are working for me on purpose. So this is pretty sweet. We've got the core of Yahtzee going. Obviously, the things we don't have yet are the ability to select a choice and actually accept the turn. And so let's get into doing those. For selecting a choice, it's going to be a little bit trickier because there are so many of them. But what I think we can do, let me go ahead and see. 200. Yeah, what I think we can do is we can kind of leverage the check click function that we just put in for dice, and we can maybe leverage that in choices. So let's go ahead and try that. So if we say check the click and then self.coordinates, and inside of this function, we're going to want to select a choice, and I think we called the list of choices like choice selected or selected choice. But just like we called the global, let's do global choice selected choice. There it is. Okay. And what we need to do is say, all right, we're going to pass in coordinates, X and Y coordinates of the click, and we need to make sure that it's inside of this range of buttons. You know what? Let's go ahead. I actually want to put this inside the main game loop. I'm sorry for being such a confusing tease. But let's go down into where it's clicked. Because we already get the positions for this, and so what I'm going to do is come down here and say inside of mouse button down, after you've checked if the dice are clicked, and that order doesn't really matter too much. I'm going to add, not inside that, if event.type mouse button down. Yep. We want to check if the event position 0, so this is your X click, if it's in kind of that first rectangle. So thinking of the grid that we made, it went from 0 to 155. And the way you access just one piece of the click coordinates is with these square brackets and then a 0. And we want to say if it's between 0 and 155, then what we're going to do is we're going to check that the Y was in an acceptable position. So that would be event.pause1. And places that you could click, this is where it gets a little bit trickier, and kind of why I didn't want to put in the choice area, is because there are 2 zones that could be like valid numbers to get clicked. And so one would be 0 to 380, and then we need an OR statement in here. Or, and then 470 to, I believe it's just going to be like 680. Yeah. Okay, and then inside that if statement, I'll just put pass so I can talk about what we just did. The valid zone of like selecting something is really just 1 through 6s, and then it's not these 3 like static text, and then it's like these next 7. So I wanted to do it this way because I think it's a little bit more specific and it'll get you thinking about what number was actually clicked. But you could put it inside the function. You know, hopefully you've learned how to do that in this tutorial. So if you'd like to modify this code and actually get it in a function inside the class, go for it. That could be sweet. I'm going to do it this way. So then I'm going to just start checking. We've made sure that it's a valid position to click already. So what we're going to start doing is checking if it's in a specific range. And so what I'll do is I'll say if it's in that first 30, set this variable we're going to make called clicked equal to 0, and then we're going to go 1, 2, 3, 4, 5, 6. So let's actually just get those added. 0, 1, 2, 3, 4, 5, 6, and let's start adding 30 up to 60, 60 up to 90, 90 up to 320, 320 up to 350, 350 up to 380, 410. Actually, 380 is where we have the little jump, so the next one's 470 up to 500. And now we can keep going. Let's see, 500 up to 530, and that'll be 7. And we're going to need 8, 9, 10, 11, and 12. So I'll copy those. You'll see why I'm doing it this way, I hope, because I want to create like a blanket function that's going to see once one choice has been selected, it also needs to unselect all the other choices. So essentially, I only want you to ever be able to select one turn at a time to like fill in one thing at a time. So 590, 620, 620, going up to 650. 650 up to 680, and we'll do 680 up to 710. Can we click up to 710, or is it up to 680? I think it's only up to 680. Did I skip a number in here? 530 to 560. I did, yeah. 560 to 590. Awesome. Really cool that I messed all these up now. 590 up to 620, 620 up to 650, and then 650 up to 680. All right, I'm not crazy. So we've got this variable clicked, and so that it doesn't give us an error, just make sure you create the variable at the very beginning. And I will just set clicked. Actually, if I set equal to 1 or 0 or some initial value like that, we're going to have one number look like it got selected when the thing got started up, and I don't want to do that. So we'll do clicked equals -1. And now what we'll say, because someone just selected something, we'll make a new function that I'm going to call make choice, and we're just going to use the clicked that we just defined to kind of make this choice, and I'm just going to do this so that I can easily unselect everything else. So I'm going to say choice is equal to, actually we're going to set the selected choice equal to make choice, and then we will pass in what was clicked, and we will pass in the selected choice list, and we will pass in the done list. And you don't need it on its own Okay, and now let's go ahead and make that make choice function. So define make choice, and we passed in a few things. We passed in clicked number. We passed in, I'll just call it selected list in here. So selected. And then we also got the done list. And again, I try to use different names than what they got passed in as. If that confuses you, call it whatever makes sense to you. You should hopefully by now know how to pass variables in and also return stuff. So that I don't forget, let's remember we're passing the selected list back out. But all we really have to do in make choice is say for index in range. And then we're going to go through the length of selected, okay? And we're going to say selected at index is equal to, oop, it automatically gave me square brackets. At index is equal to false. All right, so that for loop is going through, and then it's going to set everything equal to false. And then what we'll say is if not done at my clicked number. So here's what'll let you select something. So if it's not done at my clicked number, then we're going to go through the selected list and say the selected list at my number is now equal to true. Okay, so that's pretty groovy what we just did. And it's not just done, it's done list. There you go. But if you think back to what we're actually doing in the choice class, we're not doing anything with whether or not it's selected yet. So let's go ahead and get that added into the choice because that's pretty important. Excuse me. All right, so we're going to find our choice class and we're going to go into the drawing area. And we already have whether or not selected in this self.select, but you can see we're not calling it anywhere in the draw function. And so what we'll do is we'll go down below the name text and we will say if self.select. And if it's true, then let's go ahead and do pygame.draw.rect. And now we're going to kind of give visual indication. So I'm going to use this real dark color. It's almost black, but it's actually like a really dark green technically. But I just like the way it looks. You can play around with that color, or you can just make it black if you want. I'm fine with that. So if self.selected, then what we're going to do is we're going to put a little rectangle at self.x position, self.y position, and we will make it 155 wide because that's how long the text area is, and we'll make it 30 tall. And the reason I'm doing this pygame.rect before the screen.blit for the name text is we want the text to be drawn on top of the rectangle, not vice versa. We don't want the rectangle to draw on top of the text, otherwise you'll never see your text. Okay, but let's go ahead and see if we can select these now. Not quite. Selected numbers, 182. Let's see what I did. Probably something stupid. Yep, this is not just number, this is clicked num. There's a lot of code, a lot of stuff that's bound to pop up. Let's see. 1, 2, 3, 4, 5, 6. Can I select the ones I'm not supposed to be able to? Nope. Sweet. All right, so there you go. Actually, let's investigate. For some reason, I cannot select small straight. So let's take a look at what's happening with small straight. That would be the fourth one from the bottom. Yep, because it's 560 to 90. There we go. That's why it's important to troubleshoot at various stages. Just make sure that all the functionality you expect to have, you have. And what's great is now we can roll, we can lock stuff in. You see we get correctly. We get the options below to select. Oh, we got a Yahtzee. And it even suggests stuff to you like, hey, Yahtzee would be good now. Chance is fine now. 3 or 4 of a kind is fine now. And you could still select full house. So this is very much like it was very much like actual Yahtzee, because a player could decide at any time that they want to like just give up large straight because they don't think it's going to happen. So we're making great progress. The next really important thing to do is actually to start keeping track of the score that each row has. So I'm going to go up and I'm going to create another list just like these 3 that we did for each spot. And I'm going to make one for score, but these aren't going to be true, false. These are going to be values. And we need 13 of them. So careful counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, 0, 1, 2, 3, 4, 5, 6. 12. Perfect. And I'm just going to make this list of scores, and I'm actually going to make another list of totals. So if you think of all the, let me just open it up to talk about it. Kind of all of these extras, the ones that are in black right now, are additions or things that the player doesn't really have any control over. So I'm going to make a list called totals, but basically what that is it's just like scores, but we control them behind the scenes. So I'm just going to give us a list of 7 totals because there are 7 of those fields. And we'll do 0, 0, 0, 0, 0, 0, and one more. What did I say? 7? There we go. Okay, so how are we going to use these? Well, we're going to create a new function that's going to be called check scores. And we have to give it a lot of stuff, but we're going to use that to determine what each like box's score is, and we're also going to draw that score onto the screen. So let's go ahead and just create the function check scores first, because I think then it's going to be a little bit easier to talk about it. And let's go ahead down where we are in our game loop, and let's just call this down here where we have possible equals check possibilities. What we're going to have is we're going to have the scores list equal to check scores. Okay, so scores equals check scores. And we're going to give it a few things here. We're going to tell it what's selected. So we need to tell them what our currently selected choice is. We need to give them the numbers list. And then we also need to give the possible list. And then we also want to give the existing score list. And you'll see why we're passing all of those in as we get building this. But let's go ahead and just accept that for now. I'm going to kind of copy these up here. And so you can build this function kind of any way you want to, where you could start by building the function and then call it later. But I think the important thing to think about is we're modifying how many points your current selection is worth based on what your current dice are worth. So you need to know what turn you're going for, and then you also need to know what's possible, and then you also need to know what numbers you currently have on your dice so that you can properly modify your scores list. And so I'll name these a little differently so we can keep them all straight. Numbers list and selected choice list I'll just call choice list. Okay, and scores list. There we go. All right, so let's take a look at this check scores function. It's not actually going to be that complicated for most pieces because the scoring is fairly straightforward for most of these. So what I'll do is I'm going to create a new variable that I'm going to call active equals 0, and then I'm going to say for index in range, and then length of the choice list. So this is what's currently selected as your choice. Then what I'll say is if choice list at index. And what I mean by this statement is if it's true, but if you know some Python that you know saying if this choice list at this index is equal to true, it's faster to just say if choice list at index. Then we're going to set active equal to index. Okay, so basically what this is doing is it's just letting me pull from the current like choice list, find out what's selected, and have that just as a singular variable. So I'm going to say active equals index, and now we're going to use that index for basically everything else. So if active equals 0, then points, and actually this is my mistake, this isn't a scores list, we just want this to be like current score. We don't want to modify the list in here. We just want to calculate what the current score would be just for this one. So that's another variable, actually. Current score is equal to 0. And we're going to return current score. Let me go ahead and change that. That's why you don't want to call one thing scores and then the other thing current score, because you can get a little confused in debugging. So what we're setting is the current score variable because we're only modifying one score at a time. Alrighty, so we're going to come back up into here and we're going to say not points, current score. If you currently have 1 selected, then current score is going to just be equal to the numbers list count of the value 1, because what you've done is you've said, okay, I want to put this current turn in my ones location, and then if active equals 1, then it's the exact same thing for 2, and we can just keep going through here. And since these are all checking the same value, we'll do elifs, and we'll do elif active equals 2, and then elif active equals 3, and just check 3 and 4. And you can see this is not particularly difficult code. It's just understanding kind of how Yahtzee works and how to apply not super complex code methods to real world scenarios. Okay, so once we are out of 5, we are into a little bit more just you have to know Yahtzee to know these other ones. So the next is if active is equal to 6 or active is equal to 7, because what we do in those scenarios is exactly the same. That's if you have 3 of a kind or 4 of a kind. And if you have 3 of a kind or 4 of a kind, then what you need to do is just check if possible list at active. So we're checking to see if 3 of a kind or 4 of a kind is actually currently allowed. And then in that case, current score is equal to the entire sum of the numbers list. So we can use this built-in sums function, but the only thing is else current score is going to be equal to 0. And that is because for 3 of a kind or 4 of a kind, if you select them and you don't have 3 of a kind or 4 of a kind, so you're basically saying, all right, I've selected 6, but then, so that's your active indexer, that variable. But then you say, well, it's not possible right now, then you get 0 points. But if it is possible and you've selected 6, then the score that you get is just all of your numbers added up together. And I should mention, actually, this scoring is not just the count. The score is also times the variable in there. So if you have 3 3s, then you get 9 points. If you have 3 4s, you get 12 points. So what you need to do is take the count, which is just going to tell you how many times you have each number, and you need to multiply it by that number. Sorry for missing that the first time through, but there we go. Okay, so that's 6 or 7. How about if active is 8? So 8 is, let me remember. 8 is, let's open it up. Full house. Okay. And so now we're actually into a few easy ones, because we can copy this if possible list equals active statement. And so if it's 8, then what we can do is just say current score is equal to 25. And then else current score is 0. So full house is a really easy one because it's not a total of the dice or anything like that. It's just if it is possible currently to get a full house, you get 25 points for it. And the next few are all like that. So if active is 9, meaning small straight, then you get 30 if it's possible. If it's not, you get 0. And then if active is 10, meaning large straight, then you get 40. But again, if you select large straight and you decide to do that and it's not possible, then you get nothing. Okay, and then 11 is Yahtzee. So this one's big. It's 50 points, but again, same as all the last ones if it's possible. And that's why setting these things up, even though it may have seemed weird to have one list for possibilities and one list for scores and things like that, it's actually great that we did it that way, because now we can reference, is it possible? Is it currently selected? Is it all these different things, and handle our scoring that way. And so the last one is 12. And it is way simpler. It is just current score is equal to the sum of the numbers list. And that is because it is just chance, and that's what chance is. You take your whole turn and you kind of throw it away. You say, all right, it's worth this many points. Now, this is only useful if we display the scores of each row somewhere. So let's go ahead into our choice class and back into our draw class. Where are we? That's dice. Where's choice? Here we go. All right. And let's take this. I'm going to change it up a little bit, but let's take the writing of the text. So that was my text. Let's do another one that we'll call score text. And what we're going to do is we're going to display the score just as self.score. So we obviously need to pass in a new value that we'll call score, and self.score is going to be equal to score. And we're going to put it to the right, so about 165, and we'll keep it at 10. And instead of black, I want this one to be blue. Just differentiate where it's coming from. And we'll do score text equals font.render self.score. And now all we have to do is we have to go down and we have to give everything a score. So let's see, just choice. Just wants me to change the blank lines, I bet. All right, so let's go ahead down into our choices and let's give everything a score. And it's going to be pretty easy because we already have a list for it. So it's going to be scores list, or what did I call it? Did I just call it score? Maybe. Let's see. I can't tell. We're at like 400 lines of code, 2 hours. I just called it score. All right. Cool. So here we go. Score 0. I'll copy that, and we're going to do score 1, and we'll do score 2, and we'll do score 3, score 4, score 5, and we're going to do 6. This is riveting stuff. You guys clicked on this today to watch me copy paste for 10 minutes. I know it. 7, 8, 9, 10, 11, and 12. Okay. And so, but we have to give something for everyone. And so what we're going to do is we're going to take our totals list and we're going to put that in for the score value of all the others. And we haven't done anything to check totals yet to actually like add things up. And we'll do that next, but we do have to at least give them a value. Otherwise, we're going to get an error when we try to run this if we don't give every choice something. So this will be 4, 5, and 6. Okay, and now when we run this, it's probably just going to be zeros the whole way. Actually, it's going to give us an error. Aha, yeah. It is because this is not, so self.score is not a string. You have to use str to convert it to a string. And now it should let us run. Okay, so there, we get straight zeros. It's not super exciting. It's not doing anything. And we haven't done anything yet to store like your new turn into a roll, but we do at least have them displayed. So, and we can select these, which is pretty rad, I guess. Alrighty, so let's do something with this accept turn button. It's been sitting there since very early on and we haven't done anything with it yet because I kind of needed all these pieces in place to show what that button was supposed to do. And what the button's supposed to do is pretty cool. And it's pretty easy. It closely resembles what we did for the roll button. So actually, I'm just going to start there. And I'm going to say if the accept button collides point with the event position. And then all we really have to do is check and something selected. And I'll show you how we're going to modify that in a second. And rolls left is less than 3. So this is kind of important once the game is up and running, because once you take a turn, you're going to accept a configuration. You're going to say, okay, I want these current dice to go to my score for 4s. And it's going to give you back 3 rolls. So you have to at least take 1 roll before you can accept it, just showing you did something. And then we need something selected, which I said we're going to do a new variable. So go up to the very top, make a new variable. We're going to call it something selected. And it's going to be equal to false initially. But in our code, we're just going to do a very simple check that's just going to say if true is in the selected list, then something selected equals true. And so that's pretty easy. Let me go ahead and add it. Global something selected. I think I may have done it initially inside of the click. All right, well, here's what we're going to do. Sorry about the weird delay. We're going to come down to the game loop, and we're just going to say if true in choice, selected choice, something selected equals true. Okay? And that should do it. Choice equals make a choice. And now, all right, here's that took me a minute. All right, but if it's in something selected and you click the button and you've taken at least 1 roll in this turn, then what we want to do is a whole bunch of stuff. So we want to say if the scores at 11 are equal to 50 and done at 11. So this is a little confusing why I'm doing this right now, but it's because we're going to create a function that checks all the totals, and the one that doesn't really line up is bonus Yahtzee and possible 11. But the reason I'm doing this is bonus Yahtzee is kind of a weird situation we haven't talked about yet. I just called it score. Awesome. But bonus Yahtzee means you've already gotten a Yahtzee, which is going to be what happens if there's a 50 in your score 11, because that's going to mean that you've already done a Yahtzee turn. And so 11 is done and 11 is currently possible when you accept a turn. And the reason I'm doing it this way is it's the one thing where you actually do a different turn and the score updates. So I'll talk about that a little bit more in a second, but that's actually not super important because bonus Yahtzees are like incredibly rare. It's just part of Yahtzee. So we have to include it. And then what I'm going to say is for I in range length of selected choice, it's just an easy way to get that length. If you know it's 13 long, you can put a 13 in there. But what I'm going to say is if choice, selected choice, and again, this is where if you're comfortable having much shorter variable names, it can speed things up, but this many variables, it can actually confuse you as well. So what we'll say is we're going to set done equal to true, because now you've taken that turn. We're going to set your score at that value equal to current score. So that's the purpose of the current score function. And then we're going to set selected choice equal to false. And then the last thing we have to do immediately, actually, no matter what, is something selected equal to false as well. And then we'll do another for loop, and we'll say for I in range, and we'll do length of selected dice. Oh, I call it dice selected. Amazing. And we'll unselect all of the dice as well. So we'll say dice selected at I is equal to false. So once you've finished a turn, none of the dice should stay selected. That's just a good practice. And then what I'll do, I guess, is I would like to reinitialize the numbers at something that's going to give them nonsense values. So I know I used, I think, zeros in the very beginning, but that actually is going to like technically look like a Yahtzee. So we're going to do 7, 8, 9, 10 because those are just numbers that don't have, actually, we don't even want it to be like a large straight. So these are just numbers that don't have any indication of what to draw. So it's going to clear everything out, which is good. Okay. All right, so let's go ahead and say those are our numbers. Something selected is equal to false. And I think that's all we have to do to get a turn to be accepted. So maybe that got kind of confusing, but I promise we're super close to being done with this game. So let's try to get 6. Let's see if we can get a few of them. And actually, I'm going to have to roll down until I have less than 3 turns. Okay, so let's say I have 4 6s. I want to choose 6. I've never hit accept turn before. Hopefully, this gives us 24 points. Boolean is not subscriptable. Okay. What do you mean? Line 346. If selected choice at I is not subscriptable. Well, that looks right. Oh, it's because selected choice I has to equal false. Can't just set. Okay. All right. Well, that was a slight disappointment. We've got 2s. Let's see if we can get one more 2. Okay. All right. Let's see if our math is working now. So hopefully when I hit accept turn, we're going to get an 8 for 2s. 2s is going to become black. There we go. And now, one thing we didn't do is we didn't give ourselves our new turn. So we didn't go back to rolls left. So we need to do that. Rolls left equals 3. And since it looks like it's working, I'm going to go ahead and make the initial value back to a 3. So this will be a somewhat realistic now. Okay, so click to roll. We get 2 6s. Let's roll again. Just roll again. Got 3 6s. All right, I'll take that. Let's see if we can do a second turn. We get 18. That's good. We roll our first time. We get 3s. Actually, that's a full house. Perfect. Okay. Now this should just give us 25. Okay, perfect. So I'm not going to play a whole game of Yahtzee right here because there's still work to be done. But it is fun. And it looks like it's working pretty well. So at this point, we're pretty darn close. I think there's a few things that we can maybe add, like game over condition. Because once you finish the whole game, your game actually, whoa, there's a super important thing that we haven't done at all yet, right? And you're probably screaming at me if you've watched this video the whole way through. You're like, what about all of the totals? We're not doing anything on the totals. And you're absolutely right. We need to add a function to check all of the totals. And so where we have check for everything else, check numbers, check possibilities, check scores, we need to get the totals list by checking totals. And we got to pass a few things in there. We're going to pass in the totals list. We're going to pass in the score list. And we'll also let them know whether or not it's bonus time. And I think if it is bonus time, then we want inside this function, we want them to turn bonus time off. So perfect. That should be everything we need. If we do come up on anything else while we're writing, we'll just get it added. Define check totals, and we just passed in what? We passed in the list of totals. I'm going to copy this whole thing so I know what I need to pass back and pass in. We passed in the totals, and I'll say totals list in here, and that's the score list, and then this will just be bonus. And then we are going to return our totals list, and we are also going to return bonus. Okay? All right, now let's go through this. It's going to be fairly similar to how we checked the values and how we checked if everything was possible or not, but I think it's even simpler. So totals list 0 is just this constantly updating running total of our scores list 0 through 5. So basically we just have to add up scores list 0 plus scores list 1 plus scores list 2 plus 3, you get it, plus 4 plus 5. And this list is just telling us what all of the numerical entries added together are. So we're just basically checking to see how many dot scores did you get. So all your 1s add together, all your 2s add together, all your 3s add together. And it's good that we check that first, because then the second totals, the second item in this list, is directly dependent on that. So if you think about the Yahtzee board, you get this 35-point bonus, which is totals list 0 to 1. There we go. This is if totals list 0 is greater than or equal to 63, then we get 35 points just for doing that well on the numerical value. So this is kind of how the game makes the numbers really matter. You get this big bonus if you can get at least 3 or more of each number. That's what gives you 63. So then else, you get no bonus. So this totals list 1 is just equal to 0. And that's everything we have to do for the bonus. And then the next one is actually super easy too. It's just totals list. And all you have to do is add those first ones together. So totals list 2 equals totals list 1 plus totals list 0. Okay. So what we have there is we have the top 3, and that's super useful. But now totals list 4 it has a lot more in common. I'm actually going to copy the first one. It has a lot more in common with this one. It's the total of your lower section. So 4, and that's going to be equal to score list, but not 0 through 6 anymore. It's going to be 7 plus 8 plus 9 plus 10 plus 11 plus 12, and actually plus totals 3. Totals 3. So yeah, I skipped over totals 3 because that's the Yahtzee bonus, and I would like to talk about that at the very end. So let's go ahead and just accept for now that the Yahtzee bonus gets added. And I'm going to put a new line there. The Yahtzee bonus gets added to your total of the lower section. If you have one, which you probably don't. Okay, now totals list 5. I talked about this pretty early in the video, but it is basically just a copy of totals list 2. It's just a second place to view the total of the top score, because the grand total, which is totals list 6, the grand total is 4 plus 5. So you could do 4 plus 2. It should hopefully give you the same answer. But 4 plus 5 is technically how they do it in the Yahtzee. Okay, so now I'm going to come up right above where we added for totals list 4, and I'm going to say if bonus, okay, so that variable we pass in. Then what we have to do is say totals list 3, and then we add 100 to whatever whatever was already in there. So here's the thing. You can have multiple Yahtzee bonuses and it doesn't count as a turn. So that's why we've had to multiple times during this program do something special for this one. You take a different turn even if you already got your first Yahtzee. So you do your 4 of a kind, or your 5 of a kind, or your 6s or your 1s, or even like your full house, and you have to use that turn. But if you have this second Yahtzee, you get 100 points in this value. So that's what we're doing here. But then if it's true, we also need to set bonus equal to false. And we don't have to do anything if bonus is already false. We can just ignore it. Okay. So that should do it. And let's see, what's the problem here? Multiple spaces? Okay, I don't care. And this is totals list, not totals. You gotta be careful. And then it says bonus shadows, the name from the outside list, but I don't think bonus is out here anywhere. Okay. All right, so I think that's it for checking the totals. Let's go ahead and... Oh. Bonus time is not defined. Okay, that explains that. So let's define bonus time as equal to false in the very beginning, and let's check now. All right, let's roll. Let's get 1, 2, 3, 4. That's a small straight. 5. Okay, large straight. Nice. A couple 5s, and we'll roll again. 3 5s. Accept that. Okay, so let's get a few scores in the top half of our screen. 6, roll, accept turn for 6s. And now let's get 2, 3, 4, 1, 5. Wow, that worked out. Let's get a few in the bottom half. So you can see a few really cool things happening. The upper total and lower total are automatically updating. Your grand total's automatically updating, and they're automatically adding together the various scores that you have in those sections. So this is awesome. It's working perfectly. If that's all you want, I think this is a great place to stop the game. I'm going to add a few little things that I did to my version that I just like it. But if you made it this far in this video, you are a trooper. I hope you like this program. I hope you like the explanation. If you do have any questions about what's left still, feel free to leave a comment below. Please consider liking the video, subscribing to the channel. It helps me out a ton. And let me know what you did to this game to make it your own, or if it helped you in your coding journey. I really appreciate it. If you do want to stick around for a couple more minutes, I'm just going to add like a restart button, some scoring and high scoring tracking. And then I'll also just add like a little instructions up here at the top. But you've really got a full working Yahtzee game right now. So let's just go ahead and add a few little things. So in the drawing area, where we are just drawing stuff is what we called. I'd like to add additional text that kind of tells them how to play, because they have to know like to click on a die to select it. And that's not necessarily the most intuitive thing. So we'll take this roles text and I will say instructions text. I'll just say inst text, but these are instructions. And what we're going to say in the instructions is click a die to keep or release. So that'll just tell them how to play the game. And we don't have to add how many rolls are left. That's plenty. And then all we have to do, so we're just going to move it to the right. This first one was at 15. We've got a pretty wide screen, so we'll put it at 280. I think that whole thing will fit. Yeah, click a die to keep or release. I'll say to keep it, and I'll say click on a die, and I will spell click right. Okay, so I think that's useful. Let's add a button that is for restarting, and it is only going to be if game is over. So one thing we haven't really done is handled game over. And so we'll make a new variable called game over, and it'll be equal to false right up top in the beginning. And now we will go down to where we draw our buttons, and we will kind of create another button just like these, but we'll say if game over. Then what do we want to do? We want to draw another button. Oop, shift tab. There we go. that I will call restart button, and it will be screen, it'll be black, that's fine. The only thing I think we should do is we should put it in the big gray area that's kind of in the bottom right of the screen. We're not really using it for anything right now. So I'm going to move it over to like 275, 275, I think. 275, 275. And we can keep it 280, 30. That looks fine. And then why don't I grab some text just like we did for the other two buttons. So click to roll. I'll copy that, and I guess actually we'll do it up here too just because that's where we put the other text. We'll say global game over just so I can control it from up here. And I'll say if game is over, so if it's true, back, there we go. Then what I want to do is say game over text. So I'll just call it over text. And I'll say game over, click to restart. And they're pretty wide buttons, so I think that'll work fine. Over text, and now we just need to put it at approximately the same spot that we put the button. So draw stuff, click it to keep it, release it, game over, restart, play again. We did 275, 275. We'll do 280, 280. Or I think we want to move it down a little bit more than that. So we'll do 280, 290. That'll probably look fine. If not, honestly, I'm pretty tired. Okay, so let's add what actually happens on restart. So if you click that button, that means that game over must be over. And let's go ahead and say in our clicking logic, in our event handling, mouse button, let's add a condition in here that just says if game over and restart button dot collide point with event dot pause, right? So that's saying if the game is over and you press this, then why don't we go ahead and do, let's put the restart code in a function, because as you're about to see, it's going to get kind of messy. It's a ton of code because we need to put a whole bunch of things back into their starting positions. And then we'll say game over is equal to false. So this should be the last function we have to make, I think. But what we want to do in the restart function, we don't have to really pass anything in, but we are going to basically reinitialize so many things into the positions that they start in. So we have to grab a bunch of the stuff right in the beginning. So we have a whole bunch of variables that we just want to set equal to like false. So like roll is equal to false, clicked is equal to false, or I think, yeah, clicked is equal to false. We want to set rolls left equal to 3, and we want to reinitialize all of our lists. So if we come back to the beginning, so just think of like, we basically want all of this. So I'll copy all of this. We want the game exactly how it is when it starts up, but the problem is with putting this in a function, is I would have to either pass these all in or call them all as globals. So I'll do that here, but that's probably why most people would opt to just like copy paste this code underneath that if clicked. So this is maybe not the best way to do it. I just don't like having a ton of code right there where I do the restart. So global selected choice, global if it's possible, global if we're done, global totals, global clicked, global current score. And all global does is it basically is saying, okay, grab this from the outside world. Something selected, global bonus time, and then global game over. So I would also probably recommend going through and checking which one of these you really don't have to update. I mean, technically speaking, If you just update the like scores, what's done and what's possible, you don't really need to update the choice or the selected, because we take care of that in other places. But I'm just gonna do it this way. But no, you totally could take everything right here and just put it where I called this function instead. That would be a completely valid way of doing it. I'm going to do it this way just to let me restart. And I think I'm good with that. I think that's all I'm going to add to here. I don't remember exactly what was in the GitHub upload, but that should be everything you need to play the game. If there's specific functionality that you feel like I left out and you would like me to go into depth on, just let me know in the comments if it's something quick, and I can definitely kind of try to explain it in the comments. And if not, then maybe I'll actually modify the code, and I could always send you an update if you really need some help on something. So thank you guys so much for watching this tutorial. I really hope you found it useful. If you had any questions, any comments, or anything you want to see in a future video, just be sure to let me know about in the comments below. I really appreciate likes on the videos, subscribes to the channel. It helps me out a ton. I'm really trying to get this channel going, crank out a ton of new content, and knowing that there are people watching it really helps support me. So I really appreciate that. And as always, good luck with your programming, and thanks for watching. Thanks. Bye.